Now that's my face. Cool. Hi everyone, my name is Ricardo Capuz and this is Motoko Bootcamp. First of all, I want to invite you to take this as seriously as you can without stopping getting fun and continue diving on the internet computer rabbit hole with us. Well, in this video, I will drive you through data structures and CRUD implementations. So probably you're thinking, what the fuck is that? But first, let me tell you a bit more about me. Okay, I'm a system engineer, Motoko developer, and offline-online entrepreneur. I initially met the internet computer in 2017, but sadly I started in May 2021 and full-time in January 2022. I'm Weaver's Lab founder, a non-publicly introduced yet IC lab where we are developing Elementum trading card game, Bounty Rush, that is a betting game with NFTs, and Polybits, a really cool social network with some special twists allowed only by the technology provided by the internet computer. Also, I'm co-founder of IC in Spanish, the internet computer hub for Spanish-speaking community, and Vibrant NFT art exhibition that have had its first offline event with more than 4,000 people in Argentina past year in June. That being said, you can find me on any social network with my one and only handle that is showed on screen. So let's check our scope for this lecture then. We will explore the basics of data structures, name some of them, and present their trade-offs. After that, we will explain briefly what is and how a HashMap works, and that will prepare you for the CRUD coding session. What's a data structure? As complex as it sounds, it's just a way to store, organize, and manage data. But let's check on Wikipedia. Okay, in computer science, a data structure is a data organization, management, and storage format that is usually chosen for efficient access to data. Now, in the physical world, a data structure could be a toolbox, a closet, or even a file archive where you can organize items like tools, books, folders, or any other item that you can interact with. Similar to the offline world, in computer science, data structures allows us to store and organize data. Normally, we can find two different types of data structures, linear and nonlinear. Linear data structures have elements arranged sequentially. This means that each element is attached to its previous and next adjacent element. Linear data structure also divides into two different types, statics and dynamics. Static being those with fixed size and dynamic with dynamic size. What does this mean? With the static ones, if you don't know at least a close approximation of the number of elements you will have inside your data structure, you will have to create a new data structure and reinsert all the new elements plus the old ones in order to obtain the wanted results. But with dynamic ones, you will not. You can just add another element to the data structure and that's it. Nonlinear data structures have elements placed in a non-sequential way, so you can't traverse all the elements in one run. The previous explanation don't say too much about which type is better, right? Everyone is always looking like which is the best data structure. This is the wrong question actually. You have to evaluate depending on the use case and decide based on every data structure capabilities. Some common aspects you can consider are search speed, memory consumption, insert time, and deletion time. As you may know already, in Motoko, we have to consider another factor, stable versus heap memory. If you haven't previously, please go to the stable versus heap memory lecture. For this lecture, we're going to focus on hash maps. So, what's a hash map? You can see a hash map as a box with multiple spaces. In each space, you will find a key or hashed identifier and a value. So you can easily ask for some key or identifier and get, update, or delete the value right away. More technically, a common hashmap implementation is an array with a short number of spaces where each of them contains an associated list that allows to avoid collisions. If you want a more in-depth and technical description on what a hashmap is, please go to the hashmap link on the description. Well, for some of you this may be clear, but for those who doesn't, let's check. What's a CRUD? A CRUD is an acronym that reflects create, read, update, and delete data on a data structure. Now, I will use as example a social network DApp. Let's call it polybits. Okay, assume we have all polybits posts inside a hash map with key of type nat and with the value post that you can see on screen, that have as attributes user principal, title, and description. From Polybits frontend, we can push a post via agent.js, creating an actor and calling method createPost with the attributes we already saw on post type. Okay, parenthesis here. If you're not sure what agent.js is, don't worry. Just go later to the frontend video of this bootcamp. Okay, so you use Polybits frontend to input your values and calling createPost method. Polybits backend will receive the call and its arguments. Now, the createPost method execute, creating a new unique key and registering the parameters that we pass to the post hashmap on Polybits service. Now that we have the new post registered with a really similar process as we saw with the createPost, we can read a specific post, read them all, or read by any query that we want. We can also update post data, only if we decide in our implementation that it's possible to update it, and we can delete the post. Theory is okay, but we need to see how it works in code. Now I'm going to show you a small coding session to see how you can do the CRUD with Motoko. Okay, first of all, we have to create our project directory and a couple of files that you already know. Main.mo, that is our main file for the project, and dfx.json to make the canisters configuration. Okay, now we can go to the folder where we have this. Okay, great. So these are going to be our main files. For the dfx JSON, we can define the canisters. Okay, we are only going to need one. Okay, we don't need the front-end canister for this lecture. Type Motoko. And the main file is located here. Okay, that's it for the dfx JSON. You can add the version, but I think it's not really necessary. Okay, and here we can add an actor. Okay, now we have to create our type. In this case, we're going to do the social network, so we need a post. This is the user principal with the principal, title, type text, and a description with also type text. Now we have to define the data structure that we're going to use for the posts. It's going to be a hash map, as you already know, but I wanted to show you the Motoko based library. You probably already know it. This is really important for you to check, okay? As this is a class, when we're instantiating it, we need to pass it some parameters. So we have initial capacity, okay? We have that is a nat, okay? We will start with 1. The key equality function, okay? And the key hash function, okay? This too depends on what type of key you're going to manage, okay? So in our case, we're going to define, of course, you have to say what's the type of the key and what's the type of the value when you're instantiating it. So nat is the natural number and is the type of the key we're going to use, okay? And post is the type of the value. Okay, so to instantiate, the arguments are 1 for the initial value, okay, or the initial capacity, the int capacity, nat.equal, and hash that hash, okay. This can change. This is the case because we're going to use as key 0, 1, 2, 3, 4, etc. Okay, but if we can use text also, for example, or principal. But in case of text, if we want to use UUID as the key of our hash map, we can do it. Okay, we just have to send, okay, or initialize the hash map with text equality function and with the text hash function. Okay, this is the first step. Now we have the definition of the post's hash map. I told you that we're going to use nat, okay, as the ID or as the key to manage the hash map of the posts. So we need a counter, okay, to manage it. Okay, we can declare this one as a stable, okay, in order to not lose it when we upgrade. And we can start creating our create post function. Okay, this is basic stuff that you probably already know, but I can explain the basics. Okay, here we are defining a public function that by default it's an update, okay, because we're going to create, so we're going to change the data structure, okay. We're going to update the canister, so we need this to be a public function, aka update function, okay. We need to pass some parameters. We need to pass the post because we want to insert or create a post, okay. This is the type, okay, so we need to send it in the arguments when we're calling this method from the Candy UI or from ICScan or from the front end, okay. And this is an asynchronous call because it's public. This is obviously, and we're going to return nothing basically. Cool. So now I would like to add like a simple structure for this functions, okay. auth first. We're not going to make authentications in this lecture, but it's good to notice that. Okay, now we need to prepare the data. Okay, uh, first we need to have the ID. Okay, this is the post ID count in the first create. When we create the first post, 0 is going to be the value of the ID. Okay, but we need to use it. We need to increase that counter. Okay, so yeah, this is it. Now we're going to create a post. Create post. Okay, so this is pretty simple. This is the structure. This is the function we need. Okay, and just pass as parameters the ID. This is the key of the hash map that we're going to insert in the hash map, and the post is the value that we're going to insert in the hash map. If we check the base library, we have that, the key and the value. If we check replace function, it returns a value. Okay, the put function calls the replace, so actually this is the return. Okay, the optional value. Okay, so now we only have to return confirmation. Okay, and we return confirmation this way because we're not returning anything else. We can actually return okay, but I think that's not necessary here. So I would like to notice that I'm doing this as simple as possible. There's a lot of things that I'm not doing here, so take that into account. But this is the basic structure of how a create with the hash map works. Okay, so good. Now we can create, okay, the read post function. Okay, so the read function, okay, we need it to be a query because we're not going to update the canister. Okay, so it's not necessary to be an update function, and as the query is faster, it's better for us. So yeah, pretty cool. Okay, here I'm going to use the read post. We're going to read the post. We're going to need an ID. Okay, and of course we're going to return a post. Okay, an optional post because we're not going necessarily to obtain the post with the ID the front end sent. So yeah, okay, here we have again auth. Okay, we now can query data. Okay, this way. Here we're going to get. Okay, this is the other function of the hash map, posts. Okay, dot get. Okay, and we need to send it the ID. Okay, if we go to the basic library, to the base library, we can find get, and here it is. We have the key as a parameter and the value as the return value. Okay, so as you can see, this returns an optional value. Okay, so we just need to return posts because we're also using post here. This way, no problem there. So here we can say return requested post or null. Okay, cool. No. Okay, that's a read. Now for the update function. Okay, for the update function we need two parameters. Okay, because we want to update the data structure, so we need the new data. Okay, but we also need an ID to know what post we're going to update. Okay, that's important. And we're going to return this time a text. So yeah, here again we can say we need auth. Okay, then we need to query. Okay, data let post. We can simply copy and paste this. Okay, to obtain that one. And in the third one we need to validate if exists. Okay, so here we're going to use a switch. Okay, this is a pretty awesome tool that you can use. I use it everywhere because it allows you to consider every single option, and you can have less quantity of errors. So yes, this is the response, and the cases are null because it's an optional. So you have two possible options here. You have null value and you have post value. Okay, current post. Okay, so current post. If this is an error, we're going to return. Let me copy and paste this. You're trying to update a non-existent post. Okay, and if the value is the current post, we then need to update. Okay, for object update new post data. So here we need to prepare our data. Okay, updated post with user principal. Okay, with title and with description. Okay, here I use, okay, let me finish please second. Okay, here we use current post because we're not interested in anyone changing this. Okay, I can repeat again that this is a very simple example. This is a pretty simple example. We're not using a color here to register the user principal, but that's for another lecture. So, okay, now we have almost everything we need. We're preparing the data, and after that we're going to update the post and return success. Okay, to update the post, this is also super simple. It's just we use the hash map and call the function put to, and the parameters are the ID, okay, and the updated post. Okay, that is important to be as the same type as a post. Okay, so only left returning Success. Updated successfully. Awesome. Now we have create, read, and update. We can create now the remove post. That is the last of the acronym. Okay, but it's not the last of the lecture, but it's going to be the basic one. Okay. We, of course, need an ID for this. Okay. And as always, important to authenticate if necessary. Query the data. Okay. Let's copy and paste this because we already did this one. Okay, we need to validate if exist again. Okay, as in previous steps. So I'm not going to do it again. And we now need to remove. Okay, and for remove post and return success. Return success. Okay, so here we have to posts.remove. Okay, we need to pass the ID. This is pretty simple. And we need to return value. Post has been successful. Let me copy paste this. Okay. Okay, but this could have some problems because the remove function, okay, let's see it in the base library. The remove function have returned an optional value. So here the function is going to try to return that value, and it's going to be incompatible because we're returning a text and the value that we're trying to return is a post. So it's an optional post. So yeah, here we just have to ignore. This is a pretty good utility that Motoko have. It's pretty awesome. Ignore, and it's going to ignore that this function returns the value. So okay, that's it for the what happened here. Okay, yeah, that's it for the remove post. So okay, now we have to save this and let's start the replica. I'm going to use clean to avoid any possible conflict. Okay, we have to do the FX deploy here, but in the meantime I'm going to search pretty good file that I have here to avoid rewrite all the command line. Okay, so the FX deploy, and okay, in the meantime we can copy and paste this. Okay. Okay, let me check here. Oh, this is, we have an error here, syntax error in line 31, main.mo. Okay, 31. Unexpected token async. Okay, this is the problem. Okay, now this should. Nope, another error. So let's check 61. Line 61. Okay, this is a problem. Let's check again. Oh, again. This is not that weird. You will never have everything perfect. Oh, unbound variables. Of course. We forget a pretty important thing. That we're not importing anything. And that's pretty bad. So we need to import here HashMap from base library, of course. And we need to import nat because we're using function. Okay, import nat from, let's do this. Nat, and we're going to need hash also. Hash, okay, and yeah. So now we can check, save, and check if this works. Type ID 47. Oh, of course, yeah. It's not ID, it's nat. Oh, okay. Cool. Now we save and deploy. We have some problems here. I wanted to do this way because it allows you to see how to track the issues. Main MO 43, line 43, post. Okay, of course, this is what you should return. Okay. Save and deploy. Now it's building the canisters. Okay, now we're going to create a post with a user principal. I'm passing as argument my principal. Okay. Whenever you use this, you can add a command inside a command. Okay. So that's it. So we're going to create a post with the title "Why Fully On Chain is so important" and the description: no manipulation, no cloud, no beefsteak, because being vegetarian is really better. Okay, now we have to check and read post. We're reading the post with the key 0 because this is the first post we create, and we define here as a stable the counter of the post, initializing as 0. So yes, okay. This probably won't work. Okay, because I don't know why, but Visual Studio Code terminal mess up everything. But I will do it again. Yeah, here it is. No manipulation, no cloud, no beefsteak. Why fully on chain is so important. Okay, now we can go here and try to update. We're going to update the post with the key 0, and we're changing the description to no beefsteak. So, okay. Okay. Cool. Updated successfully, but we have to check that properly. Okay. Here it is, to avoid problems with VS Code. Okay, here it is. It worked perfectly. Now we can try to update another one, okay, that doesn't exist. Okay, the key one, the post with the key 1, okay, and it's going to return. You're trying to update a non-existent post, so that's good too. Okay, and now we have to remove the post to check if this worked. Post has been successfully removed, and we can test it again with here, repost. Okay, null. Okay. Well, as you already know, you can find me on any social network this way, and I invite you to follow the organizers of this event. Thank you, Code and State, Seb, Isaac, Cedric, and for any of you that are seeing this, I hope this video works for you and you manage to kill it at the Motoko Bootcamp and in any other project you have in mind. So have a nice trip.
Right. I love this lecture. The best one.
Thank you, Seb.
I'm going to stop sharing my screen. Maybe you want to take on the questions. I've seen there are a few of them.
Good. Yeah. I only see 3 questions. I already answered them. I can read them and answer it live. And then if you have more questions, I can also answer. Okay. Vlad Avram asked, when do we need to use shared modifier for a function and when we don't require it? If we want to get the principal of the entity that is calling the function, we use shared parenthesis key caller, and that's it. Okay. I only use it when I need to know what the color is. It's like if from the front end, Seb used the application of Polybits, for example, the social network. He wants to add a new post. Okay. He add the new post in the backend with the shared keyword and the color. I can get Seb's principal directly. He can't manipulate what came from that. So that's a cool one. Okay. Second question from Julian. Didn't get why ID has type. Okay, that was a typo, an error, as you could see. How to do a CRUD if the hash map is in other canister? Okay, my answer is that you can use canister A as a bridge with a method that calls and passes the parameters to canister B to fill the hash map. But consider that there you will have to deal with update times. Okay, 2 seconds from front end to canister A, and after that 2 seconds from canister A to canister B, and that's not good for a web application. Okay, so yeah, an open question, Leonardo Gallardo. I didn't quite understand the current post on the switch. Could have you called it anything because it's a response of the switch? Yeah, the switch have you entered to the switch an optional value. We can talk only about optional values. We can do it with variants too, but maybe it's better now to talk only about optional values. Okay, you introduce in the switch your optional value that can have 2 results, the null one and the actual value you need. So in the cases, you have to have a case for the null value, and you have to have a case for the real value you need. There, you can call that value whatever you want. So I hope that answers your questions. Okay, another question of Julian. Can we make a revision about how to declare hash map and their arguments? Okay, I guess I can share my screen. Give me 1 second, please. I have this open here. Okay. Let me look for. Okay, here's the class. Okay. Here's the class in the base library, and now I want to look for the CRUD to show you the HashMap declaration. Okay, here we have. Here we're calling the module, okay, that we declare here, okay, and we want to call the class HashMap, okay. The module that we import here is this one, okay. It's the, let me take this off screen, okay. This is the module that we're importing, and here I call the HashMap class, okay, and inside the HashMap class, this class receives 3 methods: the init capacity, the equality function, and the hash function. Okay, so we need to introduce these 3 values. Okay, and also we have to decide what we're going to be our types for the key and for the value. It's like, okay, you're instantiating a class, so you need to tell the class what are the key type and what is the value type that the class is going to use, so they can know how to manage those values. Okay, so I am here declaring, okay, when instantiating the class, okay, this HashMap, this second HashMap is the class, okay, I'm telling that the NAT, the key is going to be of type NAT, and the value is going to be of type post, okay, and the post, I declare it here. So it receives init parameters, okay, and these are the init parameters, okay. I use the NAT equality function because it's the best one for this case. And here, this was an old video, but it's from the previous bootcamp, so I now do it this way better, okay. Blob hash function is the best way to use with NAT. I hope that solves part of your doubts. I'm not sure if Seb, you want to add something.
No, I just catch up 2 minutes ago, so
Okay.
I think it was good.
Cool.
I saw a question about how HashMap are stable or not stable. I don't know if you answered this one.
Okay, yeah. Let me check. The counter was stable. Was the HashMap also stable, or by default HashMaps are stable? No, HashMap are not stable. Okay. You have to deal with the pre and post upgrade to achieve persistent there. Okay, this is not a stable data structure. This is managed by the heap. Okay.
Yeah, I just want to say also, if you by default, if you don't add the stable keyword, and nothing is stable by default, like you don't have any variable that is stable by default, and you have to add the stable keyword. But you can only do that for some types, and for HashMap you cannot do it. The reason is that HashMap is a class, so you have functions on it, and anything that is a class, it cannot be stable by default. So in that case, as Ricardo said, you have to use the pre-upgrade and post-upgrade functions, which are like system functions that will run before the canister is upgraded and after. And basically what you do is you put everything of the HashMap inside an array that is stable, and then you take it back and reinstantiate the HashMap after the upgrade.
Okay, I didn't read the chat, but people were only seeing my GitHub, so I have to reshare the screen and explain again. Yeah, let me share the entire screen. Okay. Okay, cool. Now you can see. Okay. This is in Visual Studio. We are importing HashMap, okay, like this. Okay. This is calling the module, okay, on the base library, okay, and we want to call or instantiate the class. So here, this is the class. We're instantiated this, and we have to tell the class what are the parameters or the types for the key and for the value. We're using nat for the key and post for the value, and we have to give them initial parameters. So the first one is the init capacity. Okay, you can define it as 1. I always define it as 1. You have to pass the nat equality function. Okay, and before we have here the hash from the hash library, but this is not okay. Now you should use blob hash function. Okay, this is the function that the HashMap use to locate the value when you're searching for getting the values or for updating the values, okay? And the equality, of course, is the function that the HashMap used to compare, okay? So I hope that explains better. Okay, let me check the Q&A section. Okay, the counter. Okay, so every time you deploy, the counter keeps going up, but the posts are deleted. Okay. Every time you upgrade the canister, you will have all the posts deleted, because when you use heap memory based data structure, you need to implement pre-upgrade and post-upgrade. But if I included that in this lecture, would be a hell. So it's not possible. You're going to see all that in a different lecture. So yeah, but when you work with heap memory, you have to implement pre-upgrade and post-upgrade and use a stable data structure to store the values in the pre-upgrade and then pass to the data structure on the heap memory the values of the stable data structure. That's kind of the answer. Not sure if you have more questions. This time I'm not sure if people got some clarity from the lecture or got really confused.
No, I think it was good. I think some people might need to rewatch it, but it will be on YouTube, so people can go and watch and pause. Of course, it's a very important lecture, and like, yeah, it's always a lot of information to take, but yeah, I think they just need a bit more time to take everything that we have now.
Cool.
Cool.
We need time to digest it. People are saying here it's a great lecture, but no beef steak.
Yeah, and
Cool.
the music is nice.
Yeah.
We need more music in the other lectures. I was thinking about that. Okay.
Awesome.
Yeah. Okay, thank you, Ricardo. So
thank
next lecture is in 3. Well, I never know. 4 hours, I think. 3 or 4 hours. I will announce it. And it's about front end. So it will be about not totally Motoko, but more like the front end part that Ricardo was talking about, when you go on the website and you have to log in, and the principle, how you know which user is which principle, and all those kinds of questions. So see you in the next lecture, and good luck everyone with day 2.
Bye everyone. Good luck.
Thank you.